Sure.
Okay, very good. Thank you very much for joining us. Today we have Laura Doval, who moved recently from Caltech to Columbia, talking about product line design and their limited commitment. Laura, take it away. You have 1 hour and then we'll discuss. So we'll have 10, 15 minutes later for discussions. The floor is yours.
Perfect. Thank you so much really for the invitation to present at the Australasian Microeconomic Theory Seminar. It's really an honor to be here. This is joint work with Vasilikis Kreta. Basically what we're trying to think about in this paper is the feedback between the products that a firm offers and the purchase history that this generates to try to understand price discrimination. So let me start by saying something very obvious, which is that consumers and firms interact repeatedly over time. I'm going to go for the obvious examples of online shopping or purchasing a good followed by an add-on, but I'm pretty sure you guys can come up with other better examples than this. But in these situations, via other purchases, consumers reveal information either about their valuation or their willingness to pay. And this puts us in the turf of a very familiar trade-off, which is that on the one hand, when consumers self-select, what they're doing is revealing that they like one product better than other, and therefore that means that they are getting a better match with the product that they select. But on the other hand, by revealing that they match better with one product over the other, they might revealing some information about themselves that can be later on used for price discrimination. And by price discrimination, what I will mean is that the firm will charge to different consumers different prices for the exact same good produced at the exact same marginal cost. And the reason I'm being very precise about this is that this will be important in a couple of slides. So this definition will rule out a model like Musa-Rosen as a model of price discrimination, even though sometimes we do refer to Musa-Rosen as such a model. Now, anticipating that they will be price discriminated, consumers then demand rents ex ante from the firms in order to reveal their information. And this is the reason why there's a huge literature that shows that under commitment, it is very difficult to get intertemporal price discrimination. Firms anticipating that they will have to give very high payments to consumers in order to get them to reveal this information, they choose to ignore this information and not incorporate it in its pricing decisions. On the other hand, once the firm has limited commitment and therefore it cannot commit not to incorporate the information she just learned from the consumer into its pricing decision, in those models, we will observe intertemporal price discrimination, and this goes all the way back to the literature on the Ratchet effect. Now, most of the literature that studies behavior-based price discrimination, they mostly focus only on pricing decisions. And therefore, the only benefit that a consumer gets from revealing her information is that they get the possibility of buying the product. But you might think that firms use information about consumers for more things than just their pricing decisions. Many times they use this information in order to determine even what products they put on the market. So there's an efficiency reason for why firms might like to have consumers' information, which is to offer consumers better products that are better tailored to their tastes. But the flip side of this is that it is precisely the firm's product line which gives the consumers the opportunity to self-select, and therefore it gives the firm the opportunity to later on price discriminate. And therefore the product line is also another tool that the firm has to, in a sense, prevent herself from price discriminating, because it's a tool with which the firm can learn, discipline the learning, about the consumer's private information. So what we want to understand is how does limited commitment and therefore the possibility of price discrimination shape the design of the firm's product line. And we're going to study this question in a very simple two-period model, where in the first stage, the firm will choose its product line, a quality range at non-decreasing marginal cost. And this will be exactly like the linear quadratic model of Musa-Rosen. And this stage for us will represent the benefit of using information from the consumer. In the second stage, the firm will produce an indivisible good at zero marginal cost. And this is the stage that will allow us to talk about price discrimination and therefore the costs of the firm for the firm of using information that she learned in the first period. The consumer will have private information for each of the goods that the firm sells, but we're going to look at this in a setting of dynamic mechanism design. And what I mean by this is that when the consumer contracts with the firm in the first period, she doesn't know her valuation for the good in the second period. She might have more information on the firm in the second period. She might have more information in the first period about her valuation for the good in the second period than the firm does, but she does not fully know her valuation. Now, when a consumer's information evolves over time, even with commitments, you might find sometimes that intertemporal price discrimination is optimal, but the model is such that this won't be optimal in the commitment solution. So any price discrimination that I will show you will come just from the firm's inability to commit across periods. So what we're going to do is we're going to characterize the firm's optimal mechanism, and in particular, the optimal product line under limited commitment. And what we're going to show, in line with the intuition that I just told you, is that compared to the commitment solution, the firm under limited commitment will prune products from its product line. Because by curtailing the quality, the range of products that it puts in the market, it disciplines how much it learns about the consumers, and that helps her reduce the scope of price discrimination. Now, we're going to work all our way to a picture that basically maps the first period private information of the consumer to the quality that they get assigned in the first period. We're going to be looking at the linear quadratic model of Musa-Rosen. So for some of you, it might not be a surprise that in the first best, this is just a line. Basically, each type gets a quality equals to the type. If under commitment, we're going to get the typical distortion, which is that each type gets matched to a lower quality product. But something that I think is not that much appreciated about the model of Musa-Rosen is that if you look at the set of products that the firm puts in the market, in the first best or under commitment, it's exactly the same. So these models are observationally equivalent in terms of the set of products that get put in the market. Now, under limited commitment, we're going to get that actually the firm will eliminate products from the product line. It won't always look the same, but there will always be products that are not part of the product line. And the reason she does it is in order to prevent price discrimination. So by pooling consumers, she learns less about the consumer's type, and this disciplines price discrimination in the second period. Now, as you will see in 2 slides, this is a model where if you value quality higher in the first period, it is more likely that you're going to value the indivisible good higher in the second period. So there's positive correlation of valuations across period. And the reason I'm mentioning this is that what will happen in this model is that we're going to obtain price discrimination at the high end of the product line. So consumers that buy higher quality products, they will be price discriminated in the second period. In the background, part of what will allow us to solve this problem is that we're going to be applying tools from our previous work on mechanism design with limited commitment. You don't even need to know that the other paper existed. When I get there, I will tell you exactly what we're importing, so it will be self-contained. But a lot of what we do in that other paper will allow us actually to get traction in this problem, especially because we're going to have a continuum of types.
Laura, can I ask you a question?
Yes.
So
of course.
when you mentioned about the result on the second period price discrimination, so does it mean that the correlation is it's an assumption on the model? So, you know, if you have a high value for the good in the first stage, in the second stage, you're also going to have a higher value?
So it is going to be, so I'll show the model in like 1 slide. But yeah, basically your type in the first period will be tracking the probability that you have a high value in the second period. You could think one of the things that we're playing now with is the case where it's the opposite. If you value quality a lot, maybe you get a better quality product, so you don't need the add-on in the second period. But that gets us into the turf of countervailing incentives. And I can talk a little bit about that towards the end.
Okay. Thank you.
No, thank you for the question. So there's a huge literature the paper relates to, and even if I stayed past my bedtime, I don't think I'll finish covering this. But let me give a couple of shout outs. One is Johnson and Myatt, I think, are one of the first to introduce this idea of product line pruning. They're looking at a model of competition between these firms in a Musa Rosen style setting. And they find that product line pruning is a way for the firms to soften competition, because if I remove products from the space product, from the product space, I create like a local monopoly, and that softens competition by creating differentiation. There's a huge literature that looks at price discrimination, specifically to behavior-based price discrimination, but another literature that cares about how firms use information about consumers is the literature on privacy. But because these models, even with all the assumptions that I'm going to make, are not very easy to work with, these papers mostly deal with pricing decisions, and when there are multiple qualities, these are exogenously given. Now, when I solve for the model, it will remind you of this literature that looks at communication between an upstream firm and a downstream firm. And it will be the case in this model that if the firm could break up and completely forget, like the second period firm is a different unit that does not know what the first firm did with the consumer, that will allow us to restore the commitment solution. But it will be precisely the fact that it is the same firm interacting with the consumer over time that will create this feedback, and therefore the possibility for price discrimination. Are there any other questions before I start with the model? All right, thanks. So the model is pretty simple. There's a firm, a consumer, they interact over 2 periods, 2 different transactions. In the first period, the firm will produce a good of variable quality and quadratic cost. And I'm going to be denoting by X1 the period 1 payment from the consumer to the firm. In period 2, the firm has an indivisible good that it produces at marginal cost, so it only decides whether it allocates it or not. And X2 will be the period 2 payment from the consumer to the firm. Now, in this model, the consumer has private information about her valuation for each of the goods that the firm produces. In the first period, a consumer with type theta that gets quality Q1 and makes a payment of X1, her utility is quasi-linear. We're going to be assuming that theta is uniformly distributed. And in period 2, if I get the good and I make a payment of X2 and my value for the good is V, that's my utility. And we're going to be assuming that the value of the consumer in the second period can take one of 2 values, VL or VH. I have a slide later on where I tell you exactly where and why we have all the parametric assumptions. And if I told you now, it won't make a lot of sense. So if you're patient, I will tell you why we need all this structure. Now, in period 1, the consumer doesn't know her value for the good in period 2. But conditional on her type in period 1 being theta, her value in period 2 is VH with probability theta. So this is the sense in which consumers that value quality higher in period 1 are more likely to value this indivisible good higher in period 2. I'm going to, in as much as possible, so as not to generate confusion, call theta the type and V the value. But I can't promise that I will be able to stick to that throughout, but I will try.
Laura, just a quick clarification. Yes. On the previous slide, it's U1 and U2. So I'm just fearful that I might get lost. Isn't it the same consumer? Shouldn't be U1 in period 2 as well?
Oh, sorry. So I meant, I meant that the consumer's utility will be this.
Oh, got it. Thank you.
No, but that's
Yeah. So,
that's actually a good
so the
question.
index is the period.
The index is a period, and actually this makes me realize also that I should probably be indexing this by the types. Yes, and I should say that potentially you could have discounting between periods who are going to be assuming that the firm and the consumer are perfectly patient, so as not to carry more parameters around. Thank you for asking. So at the beginning of each period, what will happen is the consumer learns her new piece of private information. The firm doesn't see this, and then the firm offers a mechanism to the consumer. The consumer sees the mechanism and decides whether she accepts or rejects. If she rejects in that period, there will be no production and there will be no payments. We move into the next period if we're in period 1. But if the consumer accepts, she will participate in the mechanism, and her participation and communication with the mechanism together with the mechanism determine the allocation for that period, and then we move on to the next period. And what we're interested is in understanding what is the best equilibrium outcome for the firm. And by equilibrium, we'll be looking at perfect Bayesian equilibrium. This will allow us to capture the sequential rationality constraint that we want from limited commitment, which is that the firm's offer of a mechanism is optimal in each period, conditional on the information that she has. So we're working in a setting where the firm in period 1 cannot commit to the mechanism that she will offer in period 2. And we're going to be using Bayes rule where possible. So one thing that we mean by Bayes rule where possible is that if the firm initiates a deviation, she doesn't get to update her beliefs about the consumer.
Laura, can I ask
Yes,
one thing about the timing?
of course.
So if I understand correctly, you can not reject the offer in period 1 and still being offered a contract or a mechanism in period 2.
Oh,
so
yes,
buying in period 1 is not necessary for getting to period 2.
Exactly.
That doesn't fit very well with the add-on example, though, usually, because usually you need to buy the main good to be offered the add-on.
Yes, no, that you're absolutely right. It will turn out that if the mechanism, so in equilibrium, it will turn out to be the case that if the mechanism is rejected in the first period, it is optimal for the firm to close shop in a sense. So there will be no transaction in the second period. But we could have just, so then we could have eliminated this part. We could have said, okay, if you reject, and it will have made our lives easier because we wouldn't have to deal with the off path. But you're absolutely right that with the add-on, it's a little bit tricky.
Can I continue on Antonio's? Yes. Could I continue on Antonio's observation?
Yes.
So your answer to him is, if you don't participate in the first period, then you won't participate in the second period because the firm closes shop, right? How much does it rely on the assumption that the value in the second period is correlated with the type on the first period? Because you're going to have, I guess in equilibrium, you're going to have that low type agents in the first period won't participate, and those are the agents whose value in the second period is very likely to be low, which means the firm will actually don't care for them. But suppose I try to modify the assumption so that the value that I have in the second period not only depends on the type that I have in the first period, but let's say in the combination, if you want the product of the type and the quality that I receive in the first period. So, so what I'm trying to say is that this outcome that you have may depend on the specific assumption that you're making on the correlation of types. Is it true?
So I think that the outcome that we have, what it does depend is on the fact that if the firm gets, so in equilibrium, everyone will participate in the mechanism.
Okay.
the low and the high types, they might get zero quality, but everyone participates.
Right.
What happens is that there is a type, which is theta equals 1, that if the firm gets convinced that the person that rejected is theta equals 1, then tomorrow that type is VH, so the firm with probability 1. So the firm is willing to set up a high price, and therefore it is as if no one was buying. But so what I was telling Antonio is the thing is that having the model this way gets us in the trouble of like having to think about off-path beliefs. Mm-hmm. And actually the way he suggested to write the model would allow us to not have to think about the off-path beliefs. But it turns out that those are the only beliefs that are consistent with revenue maximization. Okay. So in a sense, even though it looks like we're choosing crazy beliefs for the firm, those are the only ones that sort of close up the equilibrium for revenue maximization. Okay. But going to your point, if I didn't have a type that with probability 1 tomorrow becomes VH, then the firm wouldn't close shop. So that the firm might offer different prices, and therefore some types might be willing, the high types might be willing to buy at the low price strictly. Are there any questions? All right. So
sorry. There's a question in the chat. So Zach is asking, can the firm use a random delivery in the second period?
Yes. It won't be optimal, but she can. So in period 2, so given that we have a finite horizon model, I will solve this sort of via backward induction. I shouldn't say backward induction because there's no subgames, but I'll solve this backwards. So in period 2, the consumer has valuation VH with probability theta, but the firm might not know theta perfectly. So I'm going to call F2 the firm's posterior belief about theta that comes potentially from having observed the consumer's allocation in period 1. Now, that means that the expectation of the posterior mean of theta, so the expectation of theta under the posterior distribution, that is a probability that the firm assigns to the consumer's type being high. And now, with that, we know we can rely on standard results to show that the optimal mechanism in the second period is basically a posted price. And what this posted price is depends on the likelihood that the firm thinks that the consumer is either VL or VH. So if the posterior mean of theta is sufficiently low, the price will be VL. If the posterior mean of theta is sufficiently high, the price will be VH. And there will be a threshold at which the firm is indifferent between setting a price of VL, serving both types of consumer, or setting a price of VH and only serving the consumer when her value for the good is high. Now, where does this threshold mu bar come from? And we will see it in a bunch of slides. It follows basically from comparing the profit of selling at VL and getting with probability 1 VL, or selling at VH and only having the consumers whose value is VH purchase. Now, when we go to period 1, we cannot say we can rely on standard results or the revelation principle to think about the firm's problem. So here's where I tell you a little bit how we're going to incorporate what we did in the other paper. So basically what I want us to do is let's go back to the basics and think of like what is the class of mechanisms that the firm can choose from, and then I'll tell you within that class of mechanisms which are without loss of generality. So we're going to be thinking about mechanisms like Myerson 1982. So mechanisms are going to be given by two message spaces. Think of this as the type reports, and these are signals that come out of the mechanism. And the mechanism basically assigns to each report a lottery over these signals, the allocation that the consumer gets in terms of quality, and the payment that the consumer makes to the firm. So how do these mechanisms work? Basically, the consumer sees the mechanism, she decides whether to participate. If she participates, she submits privately a report into the mechanism. The report determines a distribution from which we draw the signal, the quality, and the payment. This is the allocation that's going to get implemented in period 1. And the firm and the consumer observe this draw from the mechanism. So the important thing here is that the signal that comes out of the mechanism, together with the allocation and the payment, that is the piece of information that the firm uses to update her beliefs about the consumer's type, because the firm doesn't see the consumer's type report or whatever that the message report is. Now, what we do in the other paper is show that if this is a class of mechanisms that we endow the firm with, then it is without loss of generality to restrict attention to mechanisms where the mechanism will actually ask the consumer to submit a type report. And the mechanism, the space of signals that it will use, is a space of beliefs about theta. So basically, and not only we can restrict attention to these kinds of mechanisms, we're able to restrict attention to strategies where the consumer always participates in the first period. Conditional on participating, she will truthfully report theta. And once the mechanism draws a belief F2, then this is the firm's belief in equilibrium about theta. So if the firm uses the mechanism together with the strategy of the consumer, which is participate and truthfully report, and she does base rule, F2 will actually be the belief that the firm has. Now, in this model, note that you could have thought that what the firm wants to do is use as signals beliefs about VL or VH instead of beliefs about theta. But very much like in Jeff's paper in BIPS, the signal space that works to get the revelation principle is the one that tells the firm what her belief about the consumer at the end of period 1 should be, because that's her prior for period 2, and not the belief at the beginning of period 2 about the types. So that is the message space that gives you the revelation principle. Now, you still might think, look, these mechanisms look a little bit funky or complicated because the mechanism is jointly randomizing over posteriors, qualities, and payments. Now, I can always write this randomization, so this assignment of types to lotteries over these things, I can always decompose it in 2 lotteries. One that says for each type, it gives me a distribution over posteriors, and conditional on the posterior that I draw and the type that got announced, now I draw an allocation. So you could think of this as the mapping from types to distributions over posteriors, and this is the allocation. Now, what's going to be very useful for us is that once you figure out that the space of signals of the mechanism is beliefs, conditional on the induced belief, the allocation has no more information about the consumer's type, and therefore we'll be going to be able to eliminate the condition on the type. And this is just saying that beliefs are sufficient statistics. But this has 2 important implications. Economically, and this will be the force driving everything I do today, is that this is saying that the more the firm wants to tailor the allocation to the consumer's type, the more she has to learn about the consumer's type. So in these mechanisms, if the firm wants each type to have a different quality, the only way she can do this is by learning perfectly the type. The other thing that it will give us is that we are going to be able to think separately about, for each posterior, how you design the allocation, and separately how you're going to then choose how to your distribution over posteriors. And this will also be helpful for solving, as you will see in a couple of slides. Are there any questions about this? All right, you can also ask me later if something shows up. So I'm going to do one simplification, which is I'm not going to look at mechanisms that condition the posterior randomized on the allocation. So I'm going to be thinking of mechanisms where for each posterior, there's a quality assigned and a payment from the consumer to the firm. Now, this is always without loss of generality for the transfers because I have quasi-linear utilities. So instead of randomizing over the transfers, I can ask the consumer, give me the expected payment. But it might be without loss of generality for quality. It will turn out that for what I'm going to show you today, this is not the case, but it will save me one integral in the expressions that I'm going to show you. Now, one last piece of notation before we set up the firm's problem is that I'm going to denote by Q2 of BL and F2 whether the indicator that says whether the firm, if she has a belief F2, does she serve a consumer with value BL? And remember that this is basically when the posterior mean of theta is below the threshold. Why do I need this piece of notation? Because if you think about it, in the second period, the consumer only gets a positive payoff when she is of a high valuation and the firm charges a low price. And this is what determines rents in period 2. And this is the part of the payoff of period 2 that the consumer cares about. So that's why this is going to come handy. So basically, the result I showed you says that I can look for the optimal mechanism for the firm in period 1 by solving a constraint optimization problem. So I'll set up the objective for the firm and the constraints.
Laura, sorry, can I ask a question, which is probably
Of
going to
course.
sound very dumb, but so F2 are the beliefs that the firm has about the consumer type. So the first period from theta, right?
Yes.
But you also said that in your version of the relation principle, one of the conditions that holds is that the consumer report is basically her type, and the firm knows that the reports are truthful. So what I'm confused is why are you writing Q1 and X1 as function of F2? Shouldn't those beliefs be point beliefs given that the agent reports truthfully? Shouldn't they be function of the actual data reported?
Yeah, the thing is, and I should have emphasized this more, is that the consumer sends reports privately. So the firm doesn't see what the consumer says. The firm, the only things that she sees is what comes out of the mechanism.
Okay.
Then when
the
I get to
the mechanism assigns the report, which is a type, to a
yes.
belief over type or to a distribution. Yes. Okay, sorry.
Exactly.
Okay.
So the mechanism is sort of putting a wall between the firm and the consumer.
Okay, thanks.
Thank you for asking, because that's probably because I shouldn't have stopped. I'm sure that other people also had this question. I'm sorry about that. So I will set up the objective function of the firm and the constraints. It will look like a lot of algebra. I won't torture you with a lot of algebra, but I just want you to see how the problem looks like, and then I will start, I will give intuition. So if the mechanism outputs a posterior F2, basically the firm will get a payment of X1 of F2. She will produce some quality and she has to pay the cost. If that is her equilibrium belief, that will determine whether tomorrow she charges BL or VH. If at that belief it is optimal to charge BL, then she gets BL with probability 1. If it's optimal to charge VH, she's going to get VH with the probability that the consumer is of type of value VH, and that's P of theta. So what is the probability that condition of theta, the belief is F2? That is the beta thingy that I showed you before when I was splitting the mechanism. So for each type, the distribution over posteriors, and now I have to, this will be the uniform, this is my uniform distribution. So basically what the result I showed you says is that if I solve this maximization problem subject to the the consumer's participation constraint, the truth-telling constraint, and a base consistency constraint, then I'm done with characterizing the firm's optimal mechanism. So let me show you how participation and truth-telling look like, and I will spare you the base consistency constraint, which looks kind of weird in the continuum. So if the mechanism induces a posterior of F2, this is what the consumer gets in period 1. In period 2, with some probability, she's going to be of high valuation, and therefore she only gets a payoff of BH minus BL when the firm charges a low price. And participation basically says that if we calculate the expected utility using the mechanism, that has to be greater or equal than 0 because of the reasons that I was saying before. So participation is going to be a non-path event. Therefore, off the path, there is freedom for choosing beliefs, and the firm will think that she's facing the highest type, and the highest type has the highest valuation, with probability 1 in the second period. Now, what does truth-telling mean in this setting? Well, truth-telling says that type theta has to prefer her distribution over posteriors than the distribution over posteriors over type theta tilde. That's the only thing that you do when you lie in the first period, is you manipulate the firm's beliefs. And then there's a base consistency condition. Now, from this, once we have the problem set up this way, from here, what we're going to get is an envelope condition for the payoffs for the consumer that comes from the incentive compatibility constraint. And we can always do the trick in Bayesian persuasion of, instead of thinking about for each type the distribution over posteriors that it induces, we can think about the distribution over posteriors as if this was a Blackwell experiment. Now, if I use those two things, I will obtain an expression for the payoffs of the firm that only depend on the quality and on the distribution over posteriors. There's a third constraint that I'm going to get, which is a monotonicity constraint, because I have single crossing in distributions in this setting. I'm going to ignore it for now. So I'm going to solve the problem without that constraint, and then I'm going to show you one range of parameters for which what I'm going to show you is not the right solution. That doesn't satisfy the monotonicity constraint, so that is homework that I have for the next time we meet. But I will. But you will see if it's that terrible. So basically, the solution to the relaxed problem is a mapping from posteriors to qualities and a distribution over posteriors. And it's chosen to maximize an expression that I can separate in 2 bits. One is a virtual surplus for period 1 that depends on the quality. And this is, if I showed you the expression, which I promise you that you want to see, it's basically the Musa-Rosen style surplus, but in terms of distributions over posteriors. There's a second period virtual surplus, which is what comes from the sale of the indivisible good. It is not the standard virtual surplus from second degree price discrimination, because there's the fact that the firm is trying to take into account how informative theta is about B. Now, since I'm ignoring the monotonicity constraint, and because I can separate, as I said before, the design of the allocation from design of the distribution over posteriors, I can pointwise maximize. For each posterior, I can choose the optimal quality. And now I'm going to use all the parametric assumptions that I mentioned that we had. So the uniformity, the quadratic costs, and that the probability of being a high valued consumer is theta, to get an objective function that only depends on the posterior mean. And the reason is that all of the results in information design, because now this will be basically an information design problem, in the case of the continuum are only available for the case in which the objective function is only a function of the posterior mean. So I have to say that if someone is looking for something to work on and wants to help us out, I think that understanding more information design in the case of the continuum for problems like this would be really helpful, because in mechanism design, you rarely just care about the posterior mean. In general, you care about the whole distribution, you care about the hazard rate. So many of the assumptions that we're making are just so that we get the expression in terms of the posterior mean. So just to give you a sense of what are the forces, let me show you what happens if I draw these two virtual surpluses. So the virtual surplus from the Musa-Rosen problem, it shouldn't surprise you that it's convex. And it's convex because you want to match different types to different qualities. And it's higher for higher posterior means because you value matching types to qualities more the higher the type. On the other hand, the virtual surplus for the sale of an indivisible good is linear in the posterior mean, because basically when we're thinking about selling an indivisible good, we care about some expectation of VH and VL, and not necessarily VL, some transformed version of VL to take into account rents. And the jump here, this is the place where the firm in the second period is indifferent between the low and the high price. This jump is only reflecting that the firm in the first period might not agree with her future self in terms of how to break ties. Now, imagine that I could pick a distribution over if I have these two pictures, imagine that I could pick a distribution over posterior means to maximize my objective on the left-hand side, and a separate distribution over posterior means to maximize the right-hand side. Now, if you look at the literature, for instance, if you look at the Warshak and Martini, it will tell us that because the function on the left-hand side is convex, you want to fully disclose the types. And actually, to be absolutely precise, you want to perfectly disclose types above a half, because all these types are getting 0. Now, for the function on the left-hand side, sorry, on the right-hand side, it turns out that no disclosure is optimal. And one way to see it is by using tools from this paper by Ariely, Babichenko, Smorodinsky, and Yamashita, who show that in this case, if I look, what I have to do is I look at the concavified function. I'm going to assume that the prior mean is below here. And if the concavified function at the prior mean coincides with the original function, then no disclosure is optimal. So these are like off-the-shelf results. But what this tells us is that there's like a big conflict of interest. You want the information about theta for quality provision, and you want to completely forget about the information of theta for pricing in the second period. And this is actually the commitment solution. So when you have commitment, you can use information in period 1 to tailor the allocation to the consumer's type, and then you can throw this information away and just set the price equals to VL or VH, regardless of not using information about theta. But under limited commitment, this solution is not feasible, because if I learn about theta in period 1, I'm going to price discriminate in period 2 as a function of theta. And if I want to keep myself completely blind about about theta, so I learn nothing in period 1, the only thing that I can do is offer a pooling allocation in period 1. And in this case, it means giving everyone the lowest quality level. So basically, the limited commitment solution will be trying to strike some balance between these two countervailing forces. So now we're getting to the pictures. Let me, just to wrap up, show you how the optimal mechanism looks for the case of commitment. And then what I'm going to do is I'm going to build on the commitment solution. I'm going to build on top of that the limited commitment solution by playing with it. So basically what I'm doing here is I'm saying for each theta what quality they get and what price they face in period 2. So when the threshold is below a half, what the firm does is, regardless of theta, she sets a price of VH in period 2, and she serves quality only in period 1 2 types above a half. And if mu bar is above a half, then she charges a low price in period 2, but quality is the same regardless of the period 1 price. Now, where is this a half coming from? If you, the firm always likes to charge a price of VH above mu bar and a price of VL below mu bar. So 1/2 is the prior mean of theta. So when the prior mean of theta is above mu bar, which is this case, then if I just use the ex-ante information of theta, I'm going to set a price of VH in the second period. And when the prior mean of theta is below mu bar, which is this case, then just using ex-ante information of theta, I think that the consumer is likely to be of low value in period 2, so I'm going to set a price of VL in period 2. So this is basically the commitment solution. And graphically, let me skip a couple of slides. Graphically, this is, again, the first best, which is theta over the marginal cost. This is the second best, which is this expression of theta, and the product line is the same for both. Now, I'm going to keep, these guys will stay here in all the following slides, and this is so that we don't have to memorize two things. One is how the commitment pricing works as a function of mu bar, and I'm going to be shading here. I'm going to be moving mu bar as I move along, and and if you look here, you will know where mu bar is. And this is just a reminder of how pricing changes with mu bar. Sorry, with the belief about theta. So this could be theta, or it could be the posterior mean.
So you're not gonna tell us yet about the monotonicity constraint.
No, I'm going to tell you that like potentially in 10 minutes.
Okay.
Hopefully in 10 minutes. But I want to show you how the optimal mechanism looks like, how the solution to the relaxed problem looks like, and then I can tell you why monotonicity might fail. So I'm not trying to get away with it. So let's start by thinking that mu bar is less than a quarter. And let's think, so the firm, if she had commitment, she wants to keep a high price in the second period. So what would happen if the firm tries to implement the commitment solution here? Well, all these types, she's perfectly learning theta. So she wants to set a price of VH. How about these types over here? Well, if the firm only knew that they purchased the lowest quality, then what she learns is that theta is above a half. Sorry, it's below a half. And this is exactly a quarter. And we're assuming that a quarter is bigger than mu bar. So a quarter is sort of over here. So at that belief, she also wants to set a price of VH in the second period. So there's a range of parameter values where we can get the commitment solution. Basically, what the limited commitment solution does is puts more emphasis on how information is disclosed in each period. So the firm will ban, instead of telling any consumer that wants to purchase 0, instead of telling them, tell me your type, she will be like, just purchase 0 and tell me what you purchased and nothing else. And with that, she keeps herself in the dark. Now, let's increase mu bar a little bit. So we're still below a half, but above a quarter. So now if we try to implement the commitment solution, for all these types above a half, I want to do P2 equals VH. But if I only learn that consumers below a half purchase 0, because now a quarter lives somewhere over here, I want to set a price equals to VL. And that makes me sad because now I cannot implement the commitment solution, or it makes the firm sad. So what's the name of the game here? The firm is trying to convince herself that she's facing a consumer that has a high type, so as to sustain high prices in the second period. And the way she will do it is she will stretch the set of consumers that get excluded in the first, or that get the lowest quality in the first period. And the reason why this will be the optimal distortion is that if you remember this convexity, it's less costly for the firm to distort the allocation of those types. So at the beginning, those types are not the ones that she cares the most about about tailoring the good perfectly. So she would rather sacrifice them to avoid price discrimination. And by doing this, the firm sustains a high price in the second period, but she just threw out a bunch of products from the product line. Now, this is one instance where we can perfectly sign the loss from limited commitment. So the consumers are going to face the same second period price in the commitment and limited commitment solution. Now, from the first period, there's some consumers that are getting excluded or getting a low quality good, and they are worse off. But the consumers up here, they are also worse off because they are paying more for the firm's quality for the product line in the first period. And how can we tell from this picture that they have higher prices? Because when the firm knocks off products from the product line, she's knocking off opportunities for self-selection. There's less substitutes in the market. She needs to leave less friends for the consumer to reveal her information, and therefore she can charge higher prices. But even though the firm is charging higher prices for the products that she sells at positive quality, she's still doing worse off because she cannot implement the commitment solution. So this is a case where the pie has shrunk and everyone is getting less. So now, and this is the part that Antonio will be more happy to hear about, because this is where we're going to get in trouble with monotonicity. Let's consider mu bar above a half. So that means that now the firm wants to set a low price in period 2 if she had commitment. So mu bar will live somewhere over here. If the firm tried to implement the commitment solution, now she can't, because for these types, she will set a price of EH. And for these types, or at least for this guy, she will set a price of EL. And if you do the algebra, also she wants a price of EL. So she's getting price discrimination, which is costly. So what she will do is when mu bar is above a half, but not big enough, is she's going to stretch, she's going to now serve more customers in the first period, because by inviting lower types to get positive quality, she can depress her beliefs about theta in the second period. So she extends the price of VL to all these types. But still, she's going to get price discrimination at the high end of the product line. And the reason is that the guys at the top are the ones that she really cares about giving them the right quality. And therefore, she won't sacrifice that matching value for not price discrimination. And given that I'm running low on time, this is the set of parameter values for which monotonicity will break. Because what's happening here is that these types are getting a high price in the second period. And therefore, they will say, okay, if you want me to reveal that my theta is high, I want to be compensated for the fact that if I lied, I could get a rent tomorrow. So they're going to receive that rent in terms of transfers today. But then that means that the types right below, they will be like, maybe if I lie a little bit, I get higher quality today. It's true, I have to pay a little bit more, but I'm getting all that chunk of money today. And so this is a little bit like a Lafontaine Tirole, take the money and run, if anyone is familiar with that. but that is going to make it hard with monotonicity in this case. But as you let mu bar increase, the mechanism will look the same. So the firm will still do this pulling in the middle. But basically even though it looks completely discontinuous, what's happening is this dot is moving up. And as this dot moves up, this bar here moves up. And when mu bar goes to 1, basically these two things will close up. So the mechanism actually is pretty continuous how this pulling happens, but I'm not very good with LaTeX, so I cannot show you. But basically what is happening is that the firm, the higher mu bar, the easier it is to convince herself that the consumer's values, the consumer's type is low. So she needs to sacrifice less in terms of matching to generate this pooling. Now, by the way, are there any questions before I move on? So very much according to what Antonio was suggesting, all those pictures I drew basically without even talking about consumers' incentives. I was just basically describing the trade-offs that the firm has in terms of like breaking the match between type and quality and the cost of price discriminating. And this is in part one of the things that I think is nice about the tools we develop with Vasiliki, because you can get rid of the consumer, which is very difficult to deal with in limited commitment. Now, it turns out that even though in these mechanisms, the firm doesn't observe the type report, whenever the monotonicity constraint holds in the setting, in the pictures that I showed you before, the optimal mechanism can be implemented basically with the firm offering the products to the consumer and the consumer choosing, and the firm observing the product that the consumer chose. But so basically what we do with this mechanism, with this communication device in the mechanism, is instead of thinking about the consumer strategy, we turn it into the design of the information that the firm has about the consumer. And then we back out this information as a form of consumer strategy. But as I mentioned to Antonio, there's a range of parameters for which monotonicity doesn't hold, and therefore, hopefully next time we meet, I'll tell you how this works. But I think that the economics that the products are going to be eliminated, that is still going to be there. It's just that it potentially will have a weirder shape. So, oh, there's something in the chat. Sorry, I was not paying attention. Oh, it was Zach from before. So basically what we wanted to have is a model where we are studying a trade-off that is pretty policy relevant. So if you look at the documents of the FTC or the European Trade Commission about like the costs and benefits of firms using information, now with all these discussions in privacy, something that comes out of those documents is that even policymakers don't know how to trade off or how to balance the fact that sometimes firms do good things with the information that they have, but there's also the peril that down the line they will do something bad. And this model echoes a lot of the literature in the case of commitment, that if you have commitment, then this trade-off might not be there. So the firm will act as if she didn't learn anything, and if she's facing forward-looking consumers, but she will provide the match value to the consumer. But under limited commitment, we saw that this trade-off is very pervasive, and it will shape the products that the consumer gets offered. So the product line, in a sense, gets determined by the trade-off between customization and the rich purchase history that it induces. And I think that one of the things that the model highlights nicely is that even though sometimes we think in these settings of consumers choosing amongst these products as if they were offered these products out of thin air, there's a lot of endogeneity potentially between the things that they're offered and the fact that they're going to be interacting with the firm later on. And with that, I will say thank you for your comments and your attention. And if you have any questions, I'll love to hear them.
Any questions for Laura?
I have another question if she doesn't mind, if you don't mind sticking around, Laura. So you you mentioned at some point, essentially at the point at which the designer or the seller is indifferent between setting the high price and the low price, you said, oh, we're just going to commit to one thing. So we're like, you essentially don't allow randomization about how much to sell, about what to sell for that specific posterior belief going into the second period. Do you know what I mean?
Oh, yes, but we didn't commit.
I think it's
So
result, right? So you go up
it's
there.
going to be yeah, it's going to be a result like, oh, where's the slide so that I don't give everyone a stomachache with the flipping. Let me find the picture. So this is the point that you're thinking about.
Yeah.
So in the second period, the firm is perfectly indifferent. Potentially, she's randomizing. It turns out that from the perspective of period one, the firm doesn't want randomization, but she might want a different price, or sorry, a specific price. Does that make sense? So this is like in Bayesian persuasion. We are determining, when we determine the information structure, we are determining jointly how ties are broken. And we're breaking them in terms of in favor of the firm in period one.
Yeah, so I'm just wondering, because I know from other papers in this literature, like Hart and Tirole, that the indifference for the designer in this becomes really important, because you get fixed payoffs and flexibility promised to why does that not matter here?
So my experience with the Hart and Tirole model, but is that matters off the path the same way it matters in the sale of a durable good, that you might need to randomize off the path. And like we have another paper with Vasiliki where like on the path you also get tie breaking in a very particular direction, like here, but off the path the types that are indifferent, the principal, when the principal is indifferent, he might need to randomize. But here in this part, I think it's a feature of this model. It's not that always this will be true.
Okay, so something about the continuation game so that you don't have to worry about this.
Yes, but in Lafont and Tirole, sorry, not Lafont, no, in Hart and Tirole, this randomization also does not show up on the path. So basically the Lafont and Tirole path of beliefs is, yeah.
Yes, but it matters for the uniqueness of the equilibria, and it's actually not super clear what happens if you don't allow for such randomization, right? If you kind of remove it from the possibility from this, how that affects things. So I was just, it was unclear to me, like it seemed like you ruled it actually affects what you get, but maybe you're saying that it doesn't actually matter. We could leave it in and using.
Yes, we could leave it in, because off the path, this will never bother us, because off the path, the firm will strictly prefer to charge BH in our model. But I know what you're talking about, because in the other paper, if we didn't have the randomization, we couldn't even define a strategy for the the strategy for the best response for the consumer wouldn't be well defined.
Yeah.
So you're absolutely right that generally these things matter.
It's any other question? So then join me please to thank Laura for a really nice talk. Thank you, Laura.
Thank you for having me.
So let me stop the recording now.